Welcome to Harburn 00, or indeed, welcome to Harburn 00. This is the brains of the engine shed. There's two Arduino decoders. We're going to forget about this one today, we're going to concentrate on this one here. We'll do a separate video for the sound one. This one here does the doors and also the LEDs and the lighting as well. Over here we've got an auto coupler that takes the DCC signal and converts it to something safe for the Arduino to read. We've got this here, this PCA 9685. For the video, I'll call this a PCA. It's a pulse width modulation board that runs off the Arduino using the IC2 commands. Doors, it's a rack and pinion system using a continuous servo and two Hall effect sensors. They're triggered by a little magnet on the end of each rack and pinion. Also, at the front end of it, we can't see now, there's an indicator LED to tell us when each servo is powered on. So the light's on, the servo's powered on. The light's off, there's no power going through the servo, or I should say signal. So that's the brains of it, folks. Let's take you out of the computer and we'll show you the program. In the code we've got three libraries. We've got the NMR DCC, that's to communicate with the DCC protocol. We've got the wire and also the add through pulse width servo driver, and that's to do with the communications between the Nano and the PCA. Next we've got the hardware configurations. We've got the DCC pin number 2, that is from the autocoupler to pin number 2 in the Arduino. The number of doors is 6, number of accessories is 14, and the service frequency is set to 50, as that's the standard for servos. Debug flags are in there, folks. This was to help me debug the program during it. Next we've got 3 critical timing constraints or constants. The movement timeout, if the servo hadn't reached its position for before 8 seconds or after 8 seconds, there's something wrong. And if you power up a servo longer, it's not moving, it soon goes in smoke and you get a burnt out servo. So quite a critical one, that one. Next one's your debounce delay set to 50. That's to rule out any electrical noise from the Hall effect sensors. Next one we've got then is the fade duration is 2000, so it's 2 seconds. It's set to fade up and fade down. Next we've got the data structures. This stores the data accessory decoder address mapping. Okay, so your DCC addresses, i.e. 1 to 100, which door light controls 0 to 5, 67 for the lights, and what to do if 0 equals close or 1 equals on. Next we've got the door hardware connections there, and we'll set up the channels for the PCA, and we'll set up the sensors as well, being open or closed. We've got control state as well, we've got target state where the door should be either open or closed. And then we've got the servo pulse widths. So we've got the stop 1, 372. Technically we don't need it because we are switching the servos off after the movement has reached its target. And then we've got the pulse widths to rotate to the open position and pulse width to rotate to the closed position. Movement tracking is a servo currently moving, and when did it start, the timeout protection. Next we've got the sensor state, the debounce as explained above, and the stable state for the sensor, we've got stable state for the closed sensor. We've got the last reading for debounce, the algorithms, and did the sensor last change. Status tracking, was the door moving, or was the door open, or was the door closed? The default is the door is not open, it's not closed, it'll set it to close when start up. So if you're halfway through your movement of your door and you lose power, when you start back up there, it'll sense where or where it should be, if not where it should go to, i.e. the closed position for default. Then we'll go into the one for the lights. It's much more simple, this, folks. There, it's just saying put the light on start to fade up, start to fade down. This again, you can adjust the brightness in here. The 4095 can be adjusted as well, the brightness. Then you got your global objectives, your NMRA, DCC, DC, and your add fruit pulse widths. Then we move on to the arrays to store all doors and lights, accessories, mappings. They're mapped into. Also got a little bit of debugging there, so when you've got an issue with it, you know what's went wrong, and that will do your serial print as well. We've got the LED control there, as I said before there. We can change this number here to a lesser number if I want the lights to be not so bright. And the brightness itself with it. Then you get your servo control functions, how far you want them to move, and how fast you want them to move as well. And the no holding torque, okay, so that's what I'm saying, you don't have to technically set it to stop position 372. All I'm doing is once it's got to its position, it turns the pulse wave off. In other words, there's no signal going to the servo once it's reached its position. This saves on power. Also burn out the motor. Then your debouncing for your servo, as I said before there, folks, 50 milliseconds. It cuts out the noise from the Hall effects and electrical disturbances. Your DCC command handler interprets the commands. If you put in 100, it says, oh, that's it, let's open the door. You put in 101, it says, oh, let's close the door. And it keeps on searching through their addresses all the time. The same with the light control as well. It's searching for the light control, and I'll set it there. I've got a little bit of serial print as well. It tells me what I'm doing in the serial monitor during my debugging program, so I knew it should be opening, or it should be closing, or it should have reached there, or the light should be switched on itself. And it's giving me your lights effects. Down we go, your fading, etc. The door processing, the main control. So it says read the debounce sensors, check the sensor. If it's the target, stop the servo. It's not the target, it's not moving, start the servo. If it's moving too long, the timeouts come in place and close it down. So you're debouncing the sensors as well again. Your sensors are active low, check for sensor faults. And at the target position, not the target position, and so on with it. Number 4, not the target, move towards it, not really moving, I said before. If you lose your power halfway through the door opening or closing, it'll sense, is the door open, is the door closed? No, it's no, let's close the door. So that's that. Like I say, you check your time out. Your door function setups here, folks. Open, closed, the sensors as well, and read your sensor states. It's got initialize them all, and you print for your debugging again. Same your light settings as well, and you got set up your Arduino at power on. So power on there, it starts the serial at 11520. That's for your serial monitor. It sets the clock up as well. It also sets the frequency for the servos. And then you go down to configure your doors. This is the main part there, folks. The door 1, for example, there, 372 is the stop position, 333 is the open position, and 420 is the close position, or how fast it goes itself. You can change these two numbers here to make your door go slower or faster. The furthest away from 372 makes it go faster, either direction, left or right. And you'll see down here, the door number 1 is round the other way from this one. That's because the servo is physically mounted in the opposite direction in the layout. And then you get your engine shed lights. They're set to pin 12, pins 3 as well, and then your DC ones there. So the DC addressing there, I've got doors on open, 101, 110 is close, and so on and so forth. So that's all your DCC accessories there. So if I did want to change it to accessory number 1, I just change this number from here. The same with the lights there. The lights is set to pins to address 98, address 99. It's on the accessory decoder 12 for the PCA pin, and pin 13 as well. Now you initialise your DCC, so it starts to read the way through it. Then you've got your loop. Loop's quite simple there, folks. There's not much to it. It just constantly rotates, looking for any changes of addresses, any changes of addresses for the doors, any changes of addresses for the lights. That's the end of the code there, folks. If you like a wee copy of the code, just drop my wee email, arburndoublelow@gmail.com. I'd like to thank you for watching there, folks. The next one, I'll do the code for the sound. So, cheers.